In this video, we are going to take a look at another microcontroller. It's the Raspberry Pi Pico. I'm going to show you how to hook it up to the computer and create some cool projects using MicroPython, which is a great programming language, and it's really easy to use. It's not like the C++ or the C language, which we use to program the Arduino boards. It has so many pins that we can use to create some circuits or control some devices. Also, we can read the sensor readings, including the DHT sensor. But first of all, let's create our first blink sketch. This microcontroller comes with a built-in LED, which is connected to the GPIO pin number 25. We're going to turn it on and off. But first of all, we have to hook it up to the computer using the micro USB cable. But you have to hold down the boot key. It is called the boot select key. And then we can hook it up like this. If you do that, you will see these files. So this is a little storage of the Raspberry Pi Pico. Basically, we are going to put our code in here, which will be executed in the Raspberry Pi Pico. But first of all, let's open up this HTML file, and I'm going to open it up in Google Chrome. We're going to select the Pico series, which includes different kind of microcontrollers, including the Pi Pico or the Pi Pico W, which is this microcontroller that comes with the Wi-Fi capability. We're going to talk about it as well. Here we have all of the features, like the processor. It is a dual Cortex processor, which means it is a little bit faster than the Arduino. I highly recommend you to read about it. Under here we see that it comes with a temperature sensor, which is really great. One of the first things that you need to know about the microcontroller that you use is the pin out diagram, so that we can know how to program these. For example, the built-in LED is connected to the GPIO pin number 25. We're going to turn it on and off in this tutorial. And to do that, we need to move on to the MicroPython programming language. And if you don't know what is MicroPython, it is a version of Python that is optimized for microcontrollers to write the code and create your projects. To be able to use it, we have to download this file. If you are using the Pi Pico or the Pi Pico W, let's go ahead and click on it. And I'm going to put it on my desktop. Then we could simply drag and drop the file to this storage. Our next step is to install an IDE or Integrated Development Environment. For the Arduino boards, we use the Arduino IDE. But for the Pi Pico, we're using MicroPython, and the IDE that we use for that is Thonny. Just go to this link, thonny.org, and select the operating system that you have. For me, I have a Windows machine, and I'm going to install the latest version. The same thing, I'm going to put it on my desktop. So it's going to install Python as well as the MicroPython version. Let's go ahead and execute it. Just double click on it. The steps are really easy. Hit next and install. Accept. I'm going to leave everything as default. We can create the desktop icon. And finally, we can hit install. And there you go. We've successfully installed the Thonny IDE. Let's hit finish. We have the desktop icon. We can open it up. And let's go. Now, the first thing that we need to do is to tell Thonny that we are going to use MicroPython to program this board that is connected to the computer by going to Run and Configure Interpreter. By default, it is set to local Python, but I'm going to use MicroPython for the Raspberry Pi Pico. For the port, it's going to try to detect it automatically, or we can select it. Let's hit OK. Here we have the MicroPython version. It's 1.23, and we can write a Python code, which is going to be executed by the Raspberry Pi Pico. For example, if we write print to print something, like hello world, and hit enter, the Raspberry Pi Pico will execute it, and we have the message hello world. But we are going to write a main sketch. For example, let's try to turn on this LED, which is connected to the GPIO pin number 25. To do that, we have to import a package, which is like a library. We use include, sorry, it's not include. We use import for Python, and the name of the library, like machine, which allows us to create our pin or declare it inside our code. We can give it a name, like LED equals, and we use machine dot. Then we have the pin class. We use this to create a pin object that takes in two parameters. The first one is the pin number, which is 25, and the second parameter is like the pin mode to tell Thonny that we are going to use this pin as output to turn it on and off, or to read from it, like the sensor. In our case, we are going to use machine.pin, then dot out, which means output. Next, we can turn it on using LED dot, and we have this method or function, which is called value, that takes in 0 to turn the LED off, or 1 to turn it on. There is also another command like on, which can do the same thing. So another advantage of Python that it's really easy to write. Let's check if it's working by going to run and run current script. And there you go, the LED turns on and it's green LED. Let's create something more interesting, like the blinking LED sketch. We'll be able to turn on and off this LED. We have to call some kind of a loop that is called over and over again. In MicroPython, or Python in general, we use the while loop. Just write while it's true, then colon, and hit enter. So everything that we put right here is going to be called over and over again, because this condition is always true. Each time we are going to turn the LED on using LED.on. Then we have to turn it off over and over again using LED.off. If we give the sketch a try using run and run current script, so here true is not recognized. I think it starts with an uppercase T. And let's hit run again. You notice nothing is happening because the LED is turning on and off so fast and we can't see it using our eyes. To prevent that, we need to add some kind of a delay. For example, we need to tell the program to wait for 1 second. In MicroPython, we have to import another package or library using import, and it is called time. Under this library, we have another function or method by typing time.sleep, and this takes in the number of seconds that we need to wait, like 0.5 sec. Then we turn it off and wait for half a second again. I'm gonna copy it and paste it. Now let's hit run. And there you go, we have created our blinking LED sketch. The LED is turning on and off. We are going to take a look at another new components, like the push button, so that we can control this LED, or how to use the sensor, including the AR sensor. It is called the obstacle avoiding sensor as well, because we can use it to detect whether we have an object in front of it or not. We can turn on and off the LED based on the situation. First, you need to understand the breadboard. It's a clever way to connect components like the LED. As you can see, we have some points, and all of the points in the same column are connected to each other to connect the lead of the ohm resistor with the LED. We need to put them in the same column, and each column is separated from the other one because we need to separate the leads, like the LED leads. And you see that we have this middle line, which means all of the points on the right hand side are separated from the points on the left hand side. And finally we have these rails, so all of the points in the same rail are connected. So if we put a 5 volts pin to one of the points, we're gonna get 5 volts from all of these. The same thing for the ground or the minus rail. These are connected. Now that we know how this breadboard works, we are going to connect this LED to one of the pins of our microcontroller. So each pin has some kind of a number, which is called the GPIO pin, like the GPIO pin number 28, 22. Some of these output a voltage, like the 3.3 volts, or the ground, which we usually use to power up these sensors. I want to control the LED using the GPIO pin number 22 and control it from the Raspberry Pi Pico. I'm going to use these jumper wires. I'm going to connect one lead to the pin number 22, which is this one. Then I'm going to put it on the other side. We're going to turn it on and off by controlling the positive lead. It's called the anode lead. We're going to connect it to the GPIO pin number 22 by putting it in the same column. Then we are going to add the ohm resistor to protect the LED. Finally, we have to complete the circuit by connecting the other lead to the ground. To make it easier, I'm going to use this one because it's close, and it's the third pin from bottom to top. Let's try to turn it on using the Python code or the MicroPython code. If you have already used Python, we have different options to import a library or some commands. We can use import machine, or if we want to import a specific class like the pin class, we can use from the machine library, import the pin class, and here it's going to be much simpler. We could directly use pin, and here we are going to use pin.out because we have imported this class specifically. Now let's try it out by pressing the run button, and there you go, the LED turns on. If we want to turn it off, we can use .off and hit run again. Yep, it's working. You see that we have 4 leads, but it's symmetrical. which means we could use this side or the other one. I'm going to connect one lead to the GPIO pin number 14 and the other one to the ground. For that, we have to put it on the breadboard like this. I'm going to connect one lead to the ground, which is the third pin from this side, and the other one to the GPIO pin number 14, which is right behind it. Now we are going to tell the code that we're going to use this button as an input. Then we can check if it's 1, we are going to turn the LED on, and if it's 0, we are going to turn it off. We are going to create an object, which is going to be our push button, and call it button equals. We use the same class pin. It takes in the pin number, and in this case, we are going to use it as an input by writing pin.in to check if it's working, by adding print button, and we use dot value, and that actually returns the value of the push button. Sorry, here we have T. Now I'm gonna hit run, and we get the value 0. And if we hold down the push button, at the same time I'm gonna run the script, you see that it doesn't work because the push button is a little bit different. It's not like a sensor. It doesn't return a voltage or 0 volts. It's just trying to connect it or disconnect the leads. That's why we have to pass in another parameter, which will tell the Raspberry Pi Pico to use this push button as pull up or pull down. We simply have to add a pin dot. So pull up means that when the push button is up, like in this case, it returns 1. And when we push it down, it's gonna return 0. I'm gonna run the script again. And there you go, we get the value 1 because the push button is up. And if I press it and run it again, we get the value 0. And now we can use it in our code to turn the LED on and off. But here we are going to use a while loop so that we can control it all the time. We write while, then true, which means everything that we put right here is going to be called over and over again. Each time we are going to check if the button dot value, if it's 0, we are going to turn the LED on. We add colon, then enter. We will turn the LED on using LED.on. Then we have to get back to the same level of the if keyword so that we can check else, which means otherwise. We will turn the LED off using LED.off. And that's pretty much it. We're gonna hit run. The LED is off. And if I push the button down, it turns on, then it turns off. Now we can control some devices using our push button as an input. With the same way, we can use a sensor like the obstacle avoiding sensor, or it's called the IR sensor. This sends infrared light, and when it bounces back by an object in front of it, the receiver will read the value and it outputs a voltage. We can use this voltage to check whether we have an object or not. I've already talked about this sensor in my Arduino tutorial series. Make sure to check it out if you want. But it's really simple to use. We have the VCC that goes to the 3.3 volts of the Raspberry Pi Pico. The GND goes to the ground so that we can power up this module. And the last pin, which is called out, we are going to connect it to one of the GPIO pins so that we can check the state of the sensor and turn the LED on and off based on that. So instead of using a push button, I'm going to use this sensor. I'm going to start by connecting the middle lead, which is the ground, to the ground of the Pico. Then we have the VCC and connect it to the 3.3 volts. Make sure to select the output one that outputs the voltage, and it's the pin number 5 from this side. The sensor is working, and you will see that we have this second LED that turns on and off when I put my fingers. We are going to use the output pin to check whether we have an object or not. I'm going to use the same pin, which is the pin number 14. We're going to change the code a bit. Instead of using the button name, I'm going to change it to sensor equals pin. We're using the pin number 14. And we don't need the third option because it's related to the push button. We only have to pass in pin.in so that we can read from it. Under the loop, we are going to check if the sensor value using sensor.value equals 0. We turn the LED on. Otherwise, which means 1, we're going to turn it off. And for some applications, you have to reverse that, so it doesn't matter. Let's run the script again. The LED is off, and if I put my finger, it turns on. And that's great. Now we can interact with these devices using these sensors. We are going to talk about the LCD display, and we will create a cool project. We can read the temperature and the humidity and display it using the LCD display. So you see that the temperature is 36 Celsius and the humidity is 35%. To create this project, you're going to need few components. First, you're going to need the Raspberry Pi Pico microcontroller. We're going to use the DHT sensor and we're going to add the LCD display. So this one comes with a module that is called I2C, which allows us to control it using two pins, SDA and SEL. So I'm going to start by wiring the DHT sensor. I'm going to hook it up to the pin number 16. As I said, we have three pins, the ground, the VCC, and the data. And I'm going to start by connecting the ground to the ground of the board, which is this one, the third one from this side. Next, we have the data. I'm going to use the pin number 16. And finally, we have the VCC. So this sensor works with 3.3 volts, which is the pin number 5 from this corner. And there you go, it is powered up. Now let's write the code and get the temperature and the humidity. First, we're going to import the pin from the machine library using from machine, import the pin class. Also, we're going to need the sleep command. Next, we're going to create the DHT object, but before that, we have to import the library. Import DHT. This library is built in, and we're going to create the DHT object, or let's call it sensor, equals DHT dot, and we have the class DHT11. In here, we're going to pass in the pin. It is the pin number 16. Next, we're going to add our while loop, while true, so that we can get the temperature and the humidity. First, I'm going to wait for 2 seconds because the sensor needs a little bit of time to get the temperature and the humidity. Then we have to call the function sensor.measure so that we can measure the new temperature and the humidity values. Next, I'm going to put the temperature inside a t variable, or let's call it temp, equals sensor. To get the temperature, we use temperature, and we're going to add the humidity variable, and we use sensor.humidity. So these are built-in functions that are inside the DHT library. You don't have to care about it. And let's use print to print the temperature. And I'm going to print the humidity for now. And hit run. The first value is the temperature. And the humidity is 40%. Now we want to display this information using our LCD display. It's really easy to hook up. So we have 4 wires. The ground. I'm going to connect it to the ground of the board. We could also use the G&D pin from here. That is connected to the DHT sensor. But for the VCC, it is recommended to use 5 volts because this needs a little bit of power. And the 5 volt pin is actually labeled VBus, which is this pin. I'm going to connect it to the 5 volt pin. And yeah, it is working. Next, we have the SDA and the SEL pins. When you look at the pinout diagram, you will see that we have a few SDA and SEL pins. Some of these are labeled I2C1, and we have I2C0. For me, I'm going to use the SDA number 0 and the SEL number 0. We're going to specify that under the code. Let's connect the SDA to the GPIO pin number 0. So we have SDA. It's the yellow wire. Last but not least, we have the SEL. That goes to the SEL of the microcontroller. Unlike the DHT library, in order to use the LCD display, we have to import our library, or we have to create the files right here inside the Raspberry Pi Pico, because it's not built in. You see here we have 2 sections. We have the computer, and we have the Raspberry Pi Pico memory. To make sure that the code is running inside the Pico, we have to save the main code inside it by going to File, Save, and make sure to select the Pico microcontroller. But first we have to stop it and use File, Save. But the Pico needs to recognize the main file. That's why you have to name it like this, main.py extension, and hit OK. Now we're going to add 2 more libraries, or 2 more files. So the code is on GitHub. I'm going to add the links to these 2 files under the video description. The first one is lcd_API. I'm going to copy its code using this button and go here and create the file, or we can go to File, New, Control V, then Control S. The same thing, make sure to save it under the Pico microcontroller. And here we're going to call it LCD underscore API dot py, then OK. The second file is Pico I2C underscore LCD. The same thing, let's open it up, copy it, create the file, Control V, then Control S, and it is called Pico underscore I square C underscore LCD. Now, to be able to use the LCD display, we can add our LCD object under the main file, but first we have to import the library. So this is the main library. We are going to import a class from it. And if you open it up, you see that we have this class I2C LCD to declare it. Under main, I'm going to use from Pico underscore I square C underscore LCD, import the LCD I2C. I think C is lowercase. Make sure to copy the same class name. And from the machine library, we're going to use the I2C class so that we can store the information about the SDA and the SEL pins. So I'm going to add comma. And this class is called I2C. It's under the machine library. So this kind of display has some kind of an address that we need to get and put it inside the object. To do so, I'm going to create an object and call it I2C equals I square C. This takes in the parameters. The first one is the SDA number. So we're using I2C 0 because we have I2C 1. I'm going to use 0. Then we're going to specify the SDA pin using SDA equals pin. And in here, we have to pass in the GPIO pin number. It is 0. The second or the third parameter is the SEL equals the pin number 1. And finally, the frequency. I think for most cases, you have to use this value, 400 kilohertz. To check that our Pico is recognizing the I2C module, I'm going to use a print command and use I2C dot scan. And I'm going to use the address at the index 0 because you could use more than one module. And hit run again. Yeah, we have 63. That means our LCD is working. Now, to create the actual object that we're going to use to display the text, I'm going to call it LCD equals. We're going to use this class, which takes in a few parameters. The first one is the I2C object. Then we're going to add the address and the size of the LCD. First, we have to pass in I2C, and the address, we get it by using I2C dot scan at the index 0. So this display comes with 2 rows and 16 columns. So I'm going to pass in 2 by 16. And finally, we are going to print the temperature and the humidity using the LCD display. To do that, we have few other commands. The first one is lcd.clear and print the new values. To do that, we use lcd.putstr that takes in a string, which is a list of characters. I'm going to write temp, colon, and in front of it, we are going to print the temperature value. But the temperature value is a value. We need to convert it to a string by using str and pass in temp. Next to it, I'm going to add the Celsius, which is the unit. And in the next line, we are going to print the humidity. To do that, we need to move to the next line by using lcd.move_to. We're going to go to the column number 0 and the row number 1, which is the second row. Then we're going to print the humidity by using the same command. Here we're going to write humidity. And we're going to pass in the humidity value. And the unit is the %. So I think that's pretty much it. We have a mistake. So put str takes one string. To concatenate different strings, we have to use plus. Same thing right here. And let's run it again. And there you go. We have a temperature and a humidity device that works without the computer. So the temperature is 37 Celsius. The humidity is 36%. You could put this device inside your home. So I hope you enjoyed this video. If you have a question or comment, make sure to put it under the comment section down below. And I will see you in the next one.